Hello, everyone. As people join in, we'll give a moment or two before we start. But in the meantime, please bear with us for another 30 seconds or so. Okay, I think we should start. First and foremost, welcome everyone to the webinar today. My name is Yelena Sokova. I'm the Executive Director of the Vienna Center for Disarmament and Non-Proliferation. And it's my pleasure and our team's pleasure to welcome you from all corners of the world if you are joining us today. You saw the announcement that we're talking about the use of artificial intelligence and IoT technologies, and I will have a presentation coming from our two VCDNP experts who devoted a lot of their time to this project and the report they will be presenting today. But I just wanted to say a few words that the artificial intelligence and Internet of Things technologies, digitalization is all around us in everyday life, but even more so in various industries and applications, including in the critical infrastructure industries and nuclear industry. These technologies bring a lot of benefits and potential for optimization, for effectiveness, efficiency, but they also introduce certain risks. And we will have a discussion today about the balance between those benefits and potential vulnerabilities and risks they create. This topic is very important and timely as we grapple with how to deal with some of these technologies. The result of today's report is based on a project that we ran for almost a year, maybe a little less. But the main part of it comes from a workshop that we organized and convened in October of the past year, with specifically discussing these issues with a set of different stakeholders involved, from the industry, from AI, from regulators and others, and you'll hear more about it. But today's event and the project itself and the workshop and the report that is already on our website, you'll hear about that, would not have been possible to accomplish without generous support from the Global Affairs Canada, and we're very grateful for them. The other set of thanks I want to extend to the participants in the workshop, but also many others who contributed to the project, both with their expertise through interviews or some other contributions. So many thanks for you all. But my greatest thanks goes to Dr. Sarah K. Sluckner, our senior fellow here, who led that project and still leads it, and to Mara Tsarka, who is the researcher for the project at the VCDNP as well. I'll give them the floor in the minute to convey the main results of the project. But in the meantime, I wanted to note to our listeners that if you wish to ask questions to our speakers, please do use the Q&A function, and we should have time in the end to field some of these questions. But without further ado, I really want to hand the microphone to Sarah and Mara, who spend a lot of time on this project, and looking forward myself to hearing the key takeaways from the project and its recommendations. Sarah, to you.
So, thank you, Yelena. And while I'm on a trend of saying thank you, I'd like to repeat some of the thanks that you put out as well, but coming from me as well. That is, first of all, to Global Affairs Canada for the generous support, and not just financial, but the support throughout this project. It's been great. The second thing is I wanted to thank the workshop participants. I'll do that again in a second. Amazing group of people, so many fascinating ideas, such a great 2 days. And I know some of you are watching, and I hope that you are happy with the results of this, that we pulled together based on all these great discussions with you. And finally, thank you to all of you who are coming here and listening to us talk about what I thought was an absolutely fascinating project. I had a great time doing it, and I hope you'll have a great time hearing a bit about it. So next slide, please. So I'm going to get started today. We're going to talk about this in 3 different parts. As you can see, I'm going to start by giving you a bit of background and introduction about Internet of Things and about AI and how these are applicable in the nuclear sector. But before I get to that, I want to tell you we're going to start with that. And it's to bring everyone on the same page. Some of you in the audience are experts in this. Some of you perhaps are seeing this for maybe the second time in your lives. So I thought it was good to start this way. But then I'm going to talk about, specifically, we're going to talk about 2 different categories of how you can think about AI and IoT with respect to nuclear security. The first is AI and Internet of Things devices integrated into nuclear facilities to serve useful purposes, and what might be the security risks that will need to be balanced and how to think about them. And second of all, even if the decision is made to not integrate any of these technologies, IoT or AI, into a nuclear facility, there are still some risks from the consumer side. And my colleague Mara will be talking about that. And then we'll come back to you and talk about the recommendations we have coming out of this project. So next slide, please. So the purpose of the project, I would start so you know what the background is of what we were trying to do. And our goal was to assess some of the benefits and risks of AI and Internet of Things for nuclear security specifically. And really focus on both facility integrated technologies, what I just said a few moments ago, things that are being put into your facility for a good reason, but also consumer technologies, the ChatGPTs, the Claudes of the world that you can't prevent from going forward, and how to manage those risks. Also, the risks from IoT. Our goal is to inform policymakers, regulators, operators, and international organizations. That's a level of the kinds of conclusions and recommendations we've generated, the level of the report, which I hope you'll all certainly go read. And as we've said a few times, this was based on the findings of an expert workshop. We had people from most continents, from lots of regions. We had experts from government labs. We had academics. We had government experts who are with regulators. We had lots of people involved in this. We had industry. We really appreciated all of your participation. Without all of you, this would not have been able to be the report that it is. Thank you. Next slide, please. So let me start with what is the Internet of Things. I know everyone here has heard this, but talking about what we mean by it is probably useful. And just that first bullet says it. Network-enabled physical devices that collect and exchange data. They can do this via a wired connection. They can do it via a wireless connection, which is usually what we think about, but not necessarily everything. They can be sensors. A good example is a thermostat. Could have network enabling in it. So it can say, oh, it is now 30 degrees. It is a little bit hot in this room, and pass that information to another system that can do something with it. This kind of network capability is increasingly embedded in everyday products. And I mean products everywhere. Mara will talk more about this, but look around you and right now just think about what might have a network capability that you haven't been thinking about. Next slide. So then from IoT, from just thinking about network devices that can send out data, that can collect data, we can talk about how these fit into industrial processes. Because it's not just that these are making our lives better, worse, more interesting, different. They are also influencing how industry operates. The example I gave with the thermostat is a good example. In an industry, it could be very useful to know how hot a certain system is and send that information onto a human or a machine that would do something about it. If in a particular part of your industrial system, if something goes wrong, if it gets a little bit too hot, it's useful to send that information back to another system or to a person. These kinds of systems are used in energy, manufacturing, in transport. They're used all over. And increasingly, they're being considered in the nuclear sector. Now, if you think about it, how would this be useful? Let's go back to just any kind of sensor. There's a big difference between having a sensor that gives you a display that you have to walk by or send someone to walk by and check and write in a notebook or record in a computer, from something that will, via wireless connection, for example, send out that same information on status to another machine, to your computer, which is collecting the data. Saves you a lot of time, and it saves you probably accuracy. For a lot of these reasons, which we'll get to in a moment, this is being increasingly considered in the nuclear sector, this industrial Internet of Things, to enable large-scale, real-time data collection. Industrial Internet of Things can integrate IT, and we're going to talk a bit about this as we go on, operational technology. There's the physical technologies that are doing the processes. Next slide, please. So what is AI? Now, this is something maybe everybody here has a little bit of a different answer to. Generally, what people will say is machines that can perform tasks requiring human-like cognition. To me, it's a very common definition. It's a bit of a strange one because I don't know what human-like cognition means. But effectively, you could think of it as a task where you think this is something a human could do and a machine can't do. This means it's a very broad definition, and includes roughly 3 different types of AI. One, predictive AI, which takes a collection of data and identifies patterns and tells you what those patterns are. This is very broad. Generative AI, which creates a novel output based on information that it's been given. Like perhaps it's been given 1,000 pictures of cats, it will generate a picture of a cat based on those, but that is novel in some way. And then agentic AI, which follows it's given a goal, and then it searches, it tries to accomplish that goal. It has a lot more autonomy than the other types. Now, I don't want to get deep in this. You'll notice I'm skimming over it. That's on purpose, because I really want to get to the bottom line of what we'll talk about, but make sure that I've told you a little bit that will put this all into context. In most of these cases, the AIs use large data sets to learn from, to make the connections that they need, and to be able to produce a conclusion, identify a pattern, or to be able to produce a novel output based on those. These systems, AI systems, are increasingly integrated with IoT and IoT data streams. And particularly, you can imagine pretty easily, in the slide we were just talking about with industrial Internet of Things, how an AI could be useful. If you have a lot of Internet of Things devices all over your plant, all over your facility, they are sending out a pot of data about the status. An AI could be quite useful to sort through all of that data. Next slide, please. So now I really am going to talk about nuclear facilities. Next slide. I want to start with the benefits. We've now talked about AI and IoT in the nuclear sector. I'll give you some examples that we've picked up throughout the course of this project of different ways that this could be really quite useful in the nuclear sector. For example, to do predictive maintenance using real-time monitoring, to improve operational efficiency, to do anomaly and intrusion detection in the facility, to look at video analytics. If you have a perimeter monitoring system and you want to look at those videos and figure out if something is a deer or a person, an AI might be good at that. Access control, cybersecurity monitoring, alert management, and facility-wide pattern recognition, looking at connections between anomalies in all different systems across the plant that might provide a warning of an attack or of something going wrong that you can then act on. Next slide. But the nuclear sector is not quite like other sectors. So how? Why? Well, it is always said in almost everywhere where we talk about nuclear that the nuclear sector is slow to adopt new technologies. There are really two factors in this, and they're related with each other. One is the high consequence safety and security risk environment. Just realistically, if something goes wrong, it is possible it could go very, very wrong. Because of that, in most countries, the regulatory burden is higher than for many other industries, and rightfully so. But that makes things different. It makes it harder to make changes and add in new technologies because you need to think very carefully about what you're doing. Another difference, so it's not unique to nuclear, hydropower has the same problem, for example, is that aging facilities dominate the existing fleet. And so none of this stuff, in the 80s, no one was thinking of integrating industrial Internet of Things and AI to these facilities. So that can be challenging, wasn't designed for. The construction and licensing timelines are also very, very long. For the same reasons I was just talking about, because of the regulatory structures and the high consequences, sometimes even new builds rely on designs from the 90s. Actually, in many cases, brand new builds will rely on designs from the 90s that would have to be adjusted to integrate IoT and AI. Next slide. So that divides this question really into two questions. Talking about the benefits, and if you think about a risk-benefit calculus, you'll think about it in two parts. If you just think risk-benefit calculus for all nuclear power plants, even on a general high-level policy vision, it's not that straightforward. One useful way to bin this is first, let's talk about retrofitting existing facilities. That's going to be different than building a brand new facility that integrates AI and IoT from the beginning, both in terms of how easy it is to make it happen from an operations level, but also what the security vulnerabilities are going to be, how bad they are, and how easy they are to manage. So in an existing facility, in an older facility, of course, as we said, it wasn't designed for. And the systems might not even be compatible with modern security tools, specifically cybersecurity. However, that doesn't mean you're completely out of this. It's even if someone has a very old facility, they've said, this was going to be hard, let's not put any AI or IoT on it. It may be unavoidable to have some IoT capabilities that you're going to at least have to manage, shut off, or something, because in a lot of cases, new components that eventually the components you have are going to no longer be functional. You put in a new component to replace that old one, it may have IoT capabilities. In many cases, it's going to be true. We can return to our thermostat example. Most thermostats are now IoT enabled. So the bottom line here is that retrofitting the facilities doesn't quite get you out of having to think about this problem. Next slide, please. And new builds have different challenges. Most of these things I'm going to tell you are good. They might, I'm only going to say might, this has to be run through, but it's possible this could result in a better cost-benefit analysis than for trying to retrofit a facility. Because IoT and AI can be designed in from the beginning, you can do security by design for both your cyber and physical security and align your safety, security, and operations, knowing what your vulnerabilities might be. Next slide. So I'm not going to do this. I'm doing this in the next 5 slides. There will, however, be novel and expanded risks that will need to be managed. And briefly, an expanded cyber attack surface, data protection, data sovereignty, AI-specific concerns, human factors, and safety security interfaces are some examples. There are, of course, more. So if you do choose, whether you have a new build or retrofitting, if there's a decision made that AI and IoT will be very helpful, there's some risks that just need to be managed. That doesn't mean it shouldn't be done. It just means these are a good selection of some things that need to be thought about. Next slide. This first one is relatively straightforward. You're putting perhaps 10,000 new Internet of Things network devices into your facility. You have a bigger cyber attack surface. This needs to be managed. Off-the-shelf components that you may want to put into that facility might not have all the cybersecurity protections that you would want, so that also has to be managed. And the diversity of vendors, depending on what you're trying to do, exactly what your AI IoT solution looks like, could add extra supply chain risks or new ones, and those also need to be looked at. So you hear me say, none of this is unmanageable, but you do need to think about these things. Next slide. The next thing is, as you have a lot of IoT and IoT devices in the facility, then a lot of sensitive operational data may be being produced, and that data will need to be protected. And it needs to be protected against a malicious actor who could put it together, aggregate it, and draw conclusions from it that you don't want them to. You will also have risks to confidentiality, integrity, and availability of this data that you're going to have to think about and manage. Also, in many cases, in many countries, there may be data sovereignty concerns, particularly with respect to nuclear facilities, that need to be thought about. That data may need to stay physically within the country. In many cases, the commercial systems that are being promoted that use AI and IoT may involve cloud computing. That might violate this national data sovereignty constraints. That may increase new risks to confidentiality. So that all needs to be thought about and how that's going to fit together. So that's another set of things that need to be considered from a security point of view. Next slide. There's also the AI-specific risks. AI is a new technology. It has its own novel risks associated with it. Also not unmanageable, but they need to be thought about. Data poisoning. That is whenever some subset of the AI's training data was intentionally put in a way by perhaps a malicious actor that will make it draw the wrong conclusions at convenient moments. That's not good. Adversarial inputs. Perhaps a certain input will then result in a bad response, which was initially pre-programmed by a malicious actor. Some difficulty verifying and validating AI decisions. So an AI, or most AIs, work like a black box. Not all, but most. That is, you know what goes in and you know what comes out, but how it makes that decision, how it thinks about it, is not understood even by the people who programmed it. They reach their own conclusions in a way, and not the way that humans do. And so we need some way to verify that we are, if we give in a certain set of inputs, that we will get the output that we expect and that we trust, and that will be useful for any critical infrastructure. This is absolutely essential if AI is anywhere near it. There's also an issue of limited availability of operational data that could be used to train these AIs. And so that will also need to be thought about. There just isn't right now that much data to train an AI that is specific to a nuclear facility on. There is some, but there's a need for more data. Most of these plants have been operating analog for a very long time. Theoretically, we could have produced a lot, but in reality, there just isn't it. This has led a lot of people to talk about depending on synthetic data, so generated data that will reproduce a lot of the conditions. For normal facility status, that could work out. For abnormal conditions, it's every happy family is the same. Every happy nuclear power plant is the same. It will function a certain way. But unhappy families are always different. Abnormal facility status comes in a lot of different varieties, and that would need to be thought about carefully. Next slide. Human factors. This is one of my favorites. Everyone talks about, when we talk about AI, very often people will start talking about how important it is to have a human in the loop. So an AI doesn't make the decisions for anything critical that will involve human safety. But a human is in the loop who can says, oh yes, that is okay, that is a correct decision, go ahead and make that decision. That's great. But if that human is not knowledgeable, if that human is not reliable, if that human is not thinking about safety or security, if they are not a well-trained, psychologically reviewed human in the loop, they are not a good human in the loop. So we need to think about what those qualifications are for a useful for a functional human in the loop who will be able to make the right kinds of decisions as reliably as possible. And this is not entirely new. We've had to think about human factors in the nuclear sector for a long time, but the psychology of human AI interactions is a new factor that will come into this human in the loop. People don't understand them yet. People are falling in love with AIs. We don't know why that is, a little bit. So this needs to be understood in order to get back to that first point. And in particular, if there is a rapid response scenario, we need to know what people will do if given advice by an AI, whether they will overtrust it, undertrust it, what they will do. Next slide. And then we have to think about safety adjacent systems. And it's really 2 points on a topic that is much, much larger. We have much more in the report, and there is enough to write an entire report on in and of itself. But if you have systems that are near safety that could potentially in some way affect safety, then these same technological vulnerabilities we've been talking about increase in their potential consequences. And so if IoT and AI are anywhere near this, we need to think even more carefully and think very carefully about cyber and other manipulation of these systems. We need to think about whether that risk, which could lead to the most extreme possible consequence, is worth it, and who's going to own that risk. So we haven't given any conclusions until now, but I'm going to throw a quasi-conclusion which is a sensible approach might be just to limit IoT and AI to advisory and analytical roles when you have systems that have a potential to influence safety. That said, you're going to come back to that human in the loop in the end. So, conclusions, IoT and AI in nuclear facilities. So security resource requirements are critical to include in cost-benefit assessments for IoT and AI integration. I've just spent a very long time talking about the risks and how they're all manageable. That requires investment, that requires security measures, that needs to be put in the cost-benefit assessment for you to know if it's worth it, whether you're talking about a retrofit or a new build. Conclusion 2, retrofitting existing facilities is going to present fundamentally different security challenges than putting them into new designs. So that needs a special thought, and that needs to feed into conclusion 1 with that cost-benefit analysis and making sure your security considerations are in there. Next slide. Third conclusion, as AI and IoT are further integrated into nuclear facilities, as this goes forward, the cybersecurity risks will probably grow. And those risks will span everywhere that AI and IoT is integrated. So that could be operational, safety, security, and IT domains. You really have to think cross-domain and not just say security is its own little space, its own little walled-off universe. It's going to cover everywhere. Conclusion 4, data security is going to matter even more. We've just this whole time I've talked about nothing but data, and all of that is going to need to be secured. And so there'll just be more of it, and its security will matter. And conclusion 5, the human factors aren't going away. You can put in an AI, but it's not going to eliminate your human factors concerns. And with that, I'm going to turn to Mara for the next section, and then I will be back with you for our recommendations.
Wonderful. Thank you so much, Sarah. And from my side, hello to our viewers, and thank you so much for joining us today. Sarah just provided a terrific overview of key terms, as well as IoT and AI integrated into nuclear facilities. So I'm now going to turn to the second distinct category of risk, which is broadly available and accessible consumer IoT devices, as well as AI models and systems that could be used to increase capabilities of a malicious actor. So there we go. What are we talking about when we're talking about consumer IoT devices? So IoT capabilities, Sarah alluded to this briefly in her remarks, they're now embedded in a wide range of applications and a wide range of devices. This includes smart home appliances like your coffee maker or your microwave. It also includes wearable technologies, including also medical devices such as a pacemaker. Since these IoT devices are everywhere and spreading, they often may not be clearly labeled as having a network-enabled function, or it might not be apparent that that network-enabled function has to be manually disabled if that feature is undesirable. In addition, for things like a pacemaker, it might be difficult to disable the network-enabled capability at all. Many of these consumer IoT devices also don't have clear security controls, and they're often not checked for networking capabilities or unauthorized external connectivity. which means that once these devices actually enter a nuclear facility, they could present new pathways for cyber attacks. So how could these consumer IoT devices actually enter a nuclear facility? For starters, it could be brought in by employees or contractors via their personal electronics, be that their smartwatches, their mobile phones, networked cameras, or, as in the example before, medical devices such as a pacemaker. They could also be brought in via the supply chain. For example, they could be brought in through purchasing substitution parts on the gray market, where a lot of these parts probably don't have clear documentation of the device's security features or their networking capabilities. They could also be purchased via a perceived trusted supplier, or a malicious actor could also tamper with components while in transit, for example, by injecting malicious software on the device that would allow them access once the device enters a facility. Increased network access is another concern, and this also includes a facility's wireless network coverage, should it extend just beyond the facility's perimeters, just outside the gates, so to say. And these are just to name a few examples. As the likelihood of IoT devices is projected to grow and also included in unexpected ways and in unexpected things, it means that a lot of things will have to be added to the security control checklist to be checked for networking capabilities or unauthorized external connectivity going forward. So these risks aren't necessarily new, and a lot of them are already known by cybersecurity professionals. And there is actually already a lot of guidance out there to try to manage this risk. Guidance produced by the International Atomic Energy Agency or the International Electrotechnical Commission, as well as the International Organization for Standardization, are very useful to try to address this problem. However, as already mentioned, the ubiquity of IoT devices today and their likelihood to increase, and also in unexpected devices in the future, means that eliminating the risk is impossible, and that managing it remains a big challenge. So let's turn briefly to commercial and open source AI models and systems. These tools are widely available and widely used, likely by everyone viewing the webinar today, but they're also being used by malicious actors. Commercial AI systems could help enhance existing capabilities or even upskill less sophisticated adversaries, reducing the time needed to prepare and plan for an attack, as well as improving their skills to actually carry out the attack. For example, AI could help identify targets and potential vulnerabilities using open source and publicly available information about a type of facility. AI is also very good and continuously improving at producing increasingly more authentic, persuasive, and convincing social engineering attacks, whether this be via phishing emails, text messages, social media campaigns, deepfake images. And these attacks could help recruit insiders to provide needed sensitive information and aid in the execution of an actual attack. AI is also becoming increasingly better at generating computer code, which provides new opportunities for less sophisticated adversaries to both create and deploy malware, increasing the likelihood of conducting a successful cyber attack. So the technologies, IoT and AI combined, they actually complement each other. IoT devices generate a lot of data, and AI models and systems are very useful in analyzing that data. So what does this mean? It means that any compromise to an IoT device risks exposing sensitive data that could be used by an adversary, and the adversary could then take that sensitive data in combination with AI tools to deepen their understanding of a facility and aid in the planning of an attack. A compromised IoT device also opens a pathway for an adversary to take both leaked information from, for example, an IoT device in combination with open source information, and with the help of an AI tool, aggregate that data to draw important conclusions that they may otherwise not have had to advance their own objectives. IoT, especially due to its reliance on connectivity, could offer new pathways for a cyber attack that would need to be protected. And AI's ability to upskill less sophisticated actors, especially to develop and deploy malware, combined with IoT devices offering unexpected entry points for such malware, increases the overall likelihood of a successful cyber attack. So with this threat landscape kind of mapped out, the report draws 4 main conclusions. The first is cybersecurity risks to nuclear facilities from increasingly ubiquitous consumer IoT devices are evolving, but not new, and reliable guidance does already exist. Conclusion 2, most electronic items brought into facilities should be inspected, including those not previously considered security concerns. And I think this is going to be a big one going forward. Conclusion 3, publicly available AI systems are becoming increasingly capable, and when combined with data from IoT or IIoT devices, could significantly enhance the malicious actors' capabilities. And conclusion 4, the ubiquity of commercial IoT and AI makes it impossible to eliminate all related cybersecurity risks. And with that, I'm happy to turn it back over to Sarah to present our recommendations from the report.
Thank you so much, Mara. That was a great overview of that second type of risks that we're looking at here that will need to be managed. So now I want to talk about just a few recommendations that came out of all the discussions that you've seen up till this point. Can you get the next slide? Okay. The first recommendation is to prioritize reliability and resilience. If there is a decision, particularly for certain facilities, to go forward and become highly digitalized, then in a highly digitalized nuclear facility that will then integrate IoT and AI, nuclear security needs to prioritize reliability and resilience, and especially for cybersecurity, over the unrealistic goal of preventing every attack. So there will continually be these cybersecurity attacks. AI is going to make them more sophisticated. They're going to find some vulnerabilities. The goal, the priority, if you're going to go in this direction, would just be you need to make sure that they don't matter that much. Focus on consequence prevention, that nothing happens, and recovery, getting that plant back online, working the way it should be, as fast and as reasonably as possible. Now, that's if you choose to go in that direction. Next slide. Also, account for security from the beginning. When these solutions, when an AI and IoT solution is being considered to be integrated into a facility, the cost-benefit assessments really need to look at all of the physical and cybersecurity measures to maintain robust nuclear security when these technologies are used. That'll prevent unpleasant surprises, like everything looks like it's going to save so much money. Oh, we forgot to calculate how much work it's going to be to make sure this thing is secure. It's going to be a different calculus for new builds and retrofits. So it's also going to depend on each and every facility individually. The bottom line is it needs to be accounted for from the beginning before these solutions go in. Next slide. And learn from other sectors. We said earlier on that the nuclear sector tends to be slower than many other sectors, including other critical infrastructure sectors. They are digitizing faster, and they're using more IoT and AI. That means it's a benefit, actually, for nuclear to learn from them. Try to leverage their lessons, avoid repeating their mistakes, and find out as soon as possible by working together, by cross-pollinating how it's working and what actually turns out to be the best use of money. Next slide. And also, the pace of change is just not going to slow down. It doesn't appear to be. I mean, one could always be wrong, but the way it looks right now, the pace of change is getting faster. So that means that practical, up-to-date guidance for operators and regulators on maintaining security, nuclear security, in a rapidly changing environment needs to be continuously developed. It's not going to stop. What we have today is not going to be valid in a year or two. What I'm telling you today could be completely different next year if we are doing this in 2027. So it needs to be continuously developed and also shared internationally by international and other relevant organizations, including NGOs and industry groups. The international part here is very important because, as we talk about very often in nuclear security is fundamentally international. A problem anywhere is a problem for anyone. Next slide. And that's it. Those are our recommendations. Thank you for sitting through this. So now I'm going to encourage you to go and download the expert report. Please click on this convenient QR code. You can listen to me as I say that it's not effective, but you can also just type in, do a Google search if you want. If you don't trust me because you've been hearing about cybersecurity, you can type in to look for this particular report. It's online. It is waiting for you. And actually now I'm waiting and looking forward to all of your comments and questions. Next slide, please. Thank you. So Mark, can you just slide back on the other one just to give them a bit of time while Elena is, and with that, I would like to pass it back to our director, Elena Sakova. Thank you.
Thank you, Sarah. Thank you, Mara. Very well defined, very clear set of findings, conclusions, and recommendations. And I hope that we already have some questions, but I hope that there are more. But I want to focus on some of your recommendations that you put there. I feel like we could provide a little bit more detail looking into them. And in the first one, I want to look at, Sarah, is the first recommendation about the reliability and resilience. And your good point about prioritizing them over kind of unrealistic goal of preventing every attack. But could you say a little bit more about it? It's like, what specifically that could entail?
Well, so the absolute details of what that is will depend very much on exactly what a facility has decided to implement AI and IoT to do. But in general, it's a principle that's used in the cyber world, and it's not really that different from what is often done in nuclear security, right? You always take a graded approach to security. You prioritize what the highest value targets are, you protect those more. Here it's just saying, in addition to prioritizing your highest value targets, you can't prevent attacks coming in basically nonstop. And so you have to make those targets perhaps even things that you know are going to fail, they're going to go down, and just that it's not a big deal. Now, bringing that into a more operational security realm requires some careful thinking. How do you make sure that regardless of how many different types of cyber attacks come in, be it using AI, poisoned AI that's been installed in your system, how many of them come in through an IoT system that's been compromised, that no matter what that attack is, that it can't cause high consequences. That's just, whether it's by physics, whether it's by keeping all of this very separated from any really crucial systems, that nothing so terrible can actually be triggered by an attack on that AI and IoT system. Like I said, in terms of sheer details, like the minutia of how this is done, it will depend on every single implementation and every single facility individually, and it'll have to be considered. The bottom line is keep those highest consequence things from being able to be triggered, and you will be better off. It's not very complicated, actually. Thanks. Thank you for the good question, though.
Sounds not very complicated, but I'm sure it's still.
Oh, in practice, it's probably very complicated. Principle is easy.
Yeah, the principle is easy. Implementation is a different
Another
story.
game.
But anyway, Mara, I want you to now come to you with a question about this commercial everyday devices that we use and the potential risk that they could bring with them and capabilities. But how do you ensure that you minimize that risk, and how do you properly secure that? You know, like Fitbit or many other things that people use. And you need to think a lot, particularly if they're not marked. Any thoughts on that?
Yeah, thank you so much for the question, Elena. And you're right. I think it's extremely difficult. And just going back to one of the conclusions we drew, I think it's important to highlight not a great conclusion, but it is going to be impossible to eliminate the risk entirely. But there are certain things that can be done to actually manage the risk. And I think one, first and foremost, is actually awareness. So growing awareness about the ubiquity of IoT devices, especially things that we don't expect to have a network-enabled capability. So really just growing that awareness and being cognizant of the things that are on us, the things that are around us, and how these things might be communicating and interacting with each other. I think another big thing is making sure that security controls are applied to devices and things that we didn't consider as a security concern in the past. Now, this is going to be difficult, and I think these types of lists definitely need to be established with cybersecurity professionals. who have been kind of tracking these developments. But unfortunately, I think especially for nuclear facilities, but then also just considering how things might be coming in unexpectedly, kind of growing the list and being aware of where we might have to be doing additional due diligence would also be really good. This was mentioned in the recommendations, but learning from other industries is also another way that the nuclear sector could gain input, and just learning how other industries who might be looking at these risks and might also be utilizing these tools for their own purposes, and understanding how are they managing data security, or how are they looking at these risks, what type of risks are they seeing, what type of attacks are they seeing, how could we learn from each other, I think would be another really useful way to manage and minimize the risks. And lastly, along with sharing best practices, kind of updated guidance, so everyone is aware of what to be looking out for to try to get ahead of the curve in this regard.
Thank you, Mara. That's like, yeah, so good to how to get ahead of the curve. But one of the things that are clearly coming from the report and the discussions and recommendations, that is the pace of the change of the technology and the overall technological advancement is accelerating with every day and hour, so to speak. And it's not slowing, but we know that for regulators, whether it's on national, but particularly on international level, you're always behind. That it's the technological development outpaces basically the regulation and recommendations. But what could nuclear community do in this situation? How do you make sure that you at least addressing current level of development? I'm not even suggesting like how do you think about some of the future development ahead of us. Sarah, do you want to start?
Yeah, I'm happy to talk about it. This is, I mean, it's a really hard question in the end. It's difficult to think about how can the, again, historically slow nuclear community respond to this? How can regulators think about this? How can governments, which are also have it, most governments have a response, a response time to a major change that is much slower than the technological pace that's moving right now. So I think that the way to do it is it's going to require efforts from everybody who is part of this greater nuclear security system internationally. And the IAEA is already doing some good stuff in exactly this regard. They just had a TM not that long ago, a technical meeting that talked about nuclear security and AI and brought out a lot of these questions. So without taking the time to develop a guidance document, gave a chance for everyone to start thinking together from many different countries, many different organizations. NGOs are very useful here, and different kinds of NGOs. So I'd also call out the work from the World Institute of Nuclear Security, who are doing some great work starting to talk about AI and security as well. But it's going to take everybody trying some different opportunities, try some webinars here, do some meetings here, write some reports. They're a little more fast turn that may have to come out of smaller organizations. Again, these NGOs, some of the kind of things we're doing and others are doing to respond to that need for just pure information, understanding of where the technological situation is, what industry is asking for, what the nuclear security implications of these new technologies that industry is interested in might be, so the regulators can get themselves up to speed a little faster and look at it in a more thoughtful way. I think that's where the real help can be, but it's going to take everyone working together. Governments are also going to have to really invest in thinking about this particular issue. Regulators are going to need to have at least someone thinking about this issue part-time. So it's going to be a lot of time invested, but I think if we all work together, it is something that can definitely be managed.
Mara, do you want to add something as well?
Yeah, if I could just add to that, I think I also just want to echo what Sarah's saying, and maybe emphasize it a bit further. And that is, I think dialogue dialogue with everyone, with multiple stakeholders and with multiple industries is really a great initial first step to understand how these technologies are impacting not just the nuclear sector, but other sectors, and how are we managing that impact, but also getting the viewpoints from different stakeholders. Technologies are being considered differently from the technology developers to the cybersecurity professionals, to the guards on the ground, to the nuclear regulators. So I think really making sure that the perspectives about how these technologies are perceived, what the potential implications for them might be, or how they're even being considered in products that are being developed is a really great first step to build that awareness of the technologies, to build up the information that Sarah was already speaking to also maybe contribute to a more robust nuclear security culture going forward. And once we reach that stage, also to improve understanding of individuals' roles vis-a-vis the technologies that might be considered for their particular job title or the sector that they work in. The other thing more for nuclear regulators, some nuclear regulators have already decided to adopt a technology neutral regulatory framework. And I think as technology continues to advance, that practice could be really valuable for countries that may not have already taken that approach, because having a technology neutral regulatory framework at least could offer maybe a baseline clarity regardless of the technology being discussed. As Sarah noted, at the moment, it looks like technology is going to continue to spread, continue to grow, and it's not just going to be IoT or AI. There will be another thing on the horizon. And so it might be a good opportunity for countries who may not yet have a more technology neutral regulatory framework to maybe engage in conversation with those countries who have taken that approach and to learn from it, to try to build up a more adaptable regulatory framework and maintain robust nuclear security.
Thank you, Maura and Sarah. We don't have much time left, but we do have a number of really good questions that are coming. I'm probably going to combine, because the themes are sometimes repeating, combine them and rephrase them a little bit. And between the two of you, I'll let you to decide who's going to take that question. One is about the kind of alluded in the presentation today, but more in the report, is about the need to focus on the supply chain and some potential threats coming from it. I know we also had a separate kind of project looking on it, so maybe it's a good idea to provide a few highlights on that. The other one is about the commercial IoT devices and combination of the insider threat and kind of human factor here. So maybe that one would be good to address. And there are many other very good questions that I wish we have answered to, but I'll give you these two to start with, and then I will see how many others we can fit. Sarah?
Okay. No, there were a lot of really great questions. I was just flipping through them. On insider threats and Internet of Things, I think the answer to the question that was posed is effectively yes. That the need to both inspect commercial IoT devices and tighten personnel trustworthiness and integrity are going to be a huge part of managing risk of insider facilitated threats. They aren't the only part. I mean, in the end, the old insider threat issues, worrying about people leaving doors open, worrying about people, stealing small quantities of material, this is all going to still be issues. But a new element is going to be making sure that nobody's sneaking in some sort of device, an IoT device, that they are not facilitating these kinds of attacks. Yes, it's definitely an issue, but it's an issue that's bigger than the nuclear sector, actually. This is something that's going to be an issue for all critical infrastructure. And yeah, ultimately, to me, a lot of the most difficult and challenging problems that we have to deal with come back to humans. They come back to making sure that you have reliable personnel, that you have people who aren't going to be tempted, that you have ways of dealing with the fact that some people will be tempted to become an insider for a range of reasons you can't necessarily control. I would throw in that AI is a big risk with respect to insiders as well, because AI is developing very quickly. It's able to form relationships with people. As agentic AI, independent AI becomes a stronger force, then that will be able to actually take the lead, perhaps, in recruiting insiders. People will be able to use AI to find more information, to coerce insiders. So anyway, that was a long way of saying, yes, IoT devices, personnel trustworthiness, but also AI. Those are all going to matter going forward. Very quickly on the supply chain, I'm just going to reiterate what Elena said, and you should go read our report on supply chain, because we have a lot in there about AI and supply chain and how to think about that supply chain, both the benefits of using AI to protect the supply chain. So for example, by mapping in more detail the supply chain and finding vulnerabilities in it, finding spots where you might have a supplier that is less trustworthy than others. There's also discussion of making sure that you look at your AI supply chain, which is a unique thing that might involve, if you think about it broadly, the training data used in your AI. So think about everything, the software supply chain, the hardware, the cloud computing, all the bits and pieces that are wrapped up in having an AI. They have their own supply chain, and we need to be thinking about that. The other piece I'll throw in before I let Maria sort of fill in all the spots that I've forgotten is the importance of deepfakes and AI when you're protecting your supply chain. There may not really be such a thing as an easily trusted supplier anymore. You may think you know who you're talking to, but a deepfake could be generating the video person that you're talking to. They could be generating the emails that you think you have. They could be generating the certificates that you're relying on. Those are getting better and better. So on supply chain, there's a lot of elements of AI. Making sure your AI is in good shape. Your AI has not been compromised through the supply chain is one side. The other is making sure that consumer AI is not going to even compromise in some way your conventional supply chain. So, Mara, what have I forgotten? You're over to you.
Yeah, no, I love the last part you noted on supply chain, and especially how AI could masquerade as a perceived trusted supplier, because I think this is a real concern, and there have been clear examples of this having already taken place. Not necessarily supplier, but just genuine websites and fake employees and things like that. I just wanted to come back to the insider threat a little bit and state I fully agree with everything Sarah said. And I think that is why, in particular for insider threat, since we have already seen AI through deepfakes, through persuasive spear phishing, is becoming quite good at convincing us that it's genuine, convincing us that it's real. There is a real risk of individuals being manipulated. And so I think we really need to hone in as we're entering this new world where deepfakes are becoming more commonplace, of awareness and training for all personnel. So not just the security personnel, but really all personnel in a work stream, and really kind of go back to the basis of nuclear security culture and look at what is that baseline value that we're all working for, and kind of build it up from there to try to combat insider threat, because I think insider threat is going to be increasingly more difficult to detect maybe early on as well, and to combat. So maybe kind of going back to the roots, really focusing our efforts on awareness and training about these new modes in which people could be manipulated, and trying to combat against that, especially by reestablishing kind of the organization's values, goals, and what everyone is working towards would be a good way to try to work against that.
Thank you both. We don't have much time left, so we're going to do really rapid yes or no type of cute questions. And I would suggest you both unmute your mics, and whoever is ready to answer it first. Is there a difference in terms of the consequences and also preparedness for some of the consequences or introduction of AI, IoT, if we talk about nuclear power plants or, say, research reactors?
Yes,
What are the what's the difference in like one sentence?
consequences.
Huh?
Consequences. Most research reactors are very small. And if something goes very, very wrong, the consequences are not the same as for a very large nuclear power plant. Take the spent fuel pool, for example, of a nuclear power plant. That's going to release a lot more radiation than a spent fuel pool holding a little bit of research reactor fuel.
Sounds good. Okay, good. Is that a good idea to have a liability convention for, or some kind of code of conduct for those who produce various AI, IoT, industrial IoT devices?
Unanswerable in the short time that is provided, because that is a very complicated question and possibly worthy of its own research paper, but a great question. Okay,
the last question. Are developing countries and their facilities much more vulnerable to the cyber attacks and kind of misuse of AI, IoT?
It depends.
It
It depends. That's a short answer, because if that third world country does not has very low consequences for, like, it's a research reactor, and they haven't put anything, no IoT, no AI, not even any digitization, if everything's analog, then then a cyber attack has limited results. So it depends on what you're dealing with.
Okay. Well, thank you. Mara, I didn't see you jumping in. So what
So it's so quick.
I will give you like half a minute to add anything you wish to what has been discussed, any topic or suggestion that you want to finish our webinar.
Thank you. I think the one thing I just want to say is awareness about these risks, I think, is always the first step to trying to mitigate them. So thank you, everyone, for listening, and I do hope you read the report for more insights.
Very good. And then on behalf of VCDNP, myself, Sarah, and Mara, I want to thank our viewers and listeners for joining us today, and I hope you would download and read the report and find more details about it. But thank you, everyone, and have the wonderful rest of your day. Thank you.
Thank you, everyone. Thank you.